YouTube?
I can do that.
Yes, he will.
Okay,
I'm live.
okay.
YouTube is live.
Okay, go ahead.
Just like that.
I've got it right. I've got it. I think I can do it. Thank you, Carol. I would call this meeting to order of the wastewater treatment plant joint use board. The regular meeting conducted June the 17th, 2020.
Okay.
Yeah, have a call to order, please.
Yes, sir. Mayor Crawford is present. Mayor Holman,
Yes.
Councilor Cornelius,
Here.
Councilor Jackson,
Here.
Joey Jarvis.
Here.
And I'd like to report that just for the record, we have on via Zoom Arzik Garcia, Tim Dodge, and Ron Sena, Adam Sanchez, Karen Gutierrez, Derek Belka with Moulton Corbin and Associates. Did I forget anybody? Eric Boyda. And myself, Bertha de los Santos is here, and Councilor Jackson and Councilor Cornelius are present in the council chambers, and Jeffrey Farguson.
Sorry, guys.
Thank you.
That's all right. I think you're plenty busy.
It's crazy.
Yeah.
We're on approval of the agenda.
Okay, I'm sorry, everyone,
That's okay.
again.
We just have called it to order, do the roll call.
Okay. All right, thank you, everyone, for attending. We'll have discussion and possible action on approval of the minutes, May 20th, 2020, regular meeting.
Mayor, before we do the minutes,
Mhm.
we need to approve the agenda.
Oh, okay, I'm sorry.
That's okay.
Could I have a motion for the approval of today's agenda, please?
Mr. Mayor, move to approve the agenda as presented. Second.
Okay, we have a motion and a second. Roll call, please.
Councilor Jackson,
Aye.
Councilor Cornelius,
Aye.
Mayor Holman,
Aye.
Mayor Crawford,
Aye.
Joey Jarvis.
Aye.
Thank you.
Okay, thank you, Bertha. Move on to regular items. Item number 1, discussion and possible action on approval of minutes, May 20, 2020, regular meeting.
Mr. Mayor, move to approve the minutes as presented and written. Second.
Okay, we have a motion and a second. Roll call, please, ma'am.
Yes, Councilor Jackson,
Aye.
Councilor Cornelius,
Aye.
Mayor Holman,
Aye.
Mayor Crawford,
Aye.
Joey Jarvis.
Aye.
Thank you.
All right, thank you, gentlemen. Item number 2 is discussion and possible action on adoption of Resolution 2020-04, a resolution adopting the regional wastewater treatment plant level of service.
Mayor Crawford, members of the board, I'm Eric Boyda, the Watershed and Water Rights Director for the Village of Ruidoso. Isaac was going to present on the actual level of service, but I just wanted to give you guys an understanding of what we're doing and why we're doing it. So currently the Village of Ruidoso is undertaking a comprehensive asset management plan development for all of the utilities. And so we are, the asset management plan is going to help us look at regular maintenance and upgrades to our facilities. And so asset management plan has 5 core components, them being 1, the current state of the assets, 2, the level of service. And so that's what we're presenting to you guys today. 3, the criticality analysis, 4, life cycle costing, and 5, long-term funding. And so the level of service component is where we establish goals for the services being provided. So this will provide Isaac with kind of his targets that he'll try to meet in the operations of the plant. And Isaac, if you wanted to discuss any of the components of it or answer any of the questions about it.
Do you want me to go ahead and read off everyone? And then if you guys have any questions, you just let me know.
Yes, sir. I think that'd be good.
Good morning, Mayor and and counselors, it's weird on this, on the computer screen, but, good morning. Me and Eric went through and we, came up with a level of service for the facility. So the first thing on my list is plant will meet all NPDES permit TMDLs required by the state of an EPA. Effluent quality discharge to Rio Ruidoso will be 10% below NPDES limits 90% of the time, which we're meeting right now. We're getting well below the permit limits. The facility will remove greater than 99% of BOD and TSS coming into the facility before discharging the Rio Ruidoso 90% of the time. DMRs, biomonitoring pollutant scans, sludge reports, QA studies will be completed by the required time, 100% of the time. I try to be on schedule and never late on anything that I do out here. Any illegal discharge of any kind will be reported within 2 hours of discovery to the EPA and NED 90%, 95% of the time. All illegal discharges, however, shall be reported as required by regulations. Chemical dosage for phosphorus removal will be optimized based upon flows and chem scan units constant results once per day 90% of the time as to not overfeed and waste money. Spare parts will be kept on hand based on the criticality of need for them as defined in the asset management plan. Any spare parts used will be replenished within 1 month of use 90% of the time. All customer complaints related to public health or safety will be investigated within 2 hours of reporting to the complaint 95% of the time during regular operating hours, 8 to 5 p.m. daily. All other complaints will be investigated within 2 business days. All employees will complete the required annual hours of safety training provided by the Village of Ruidoso and safety counseling. There will be no documented instances of employees performing work without the necessary PPE. Any repairs that need to be done on equipment, pumps, motors, valves, with parts on hand will be repaired within 8 hours, 80% of the time. Monthly and quarterly scheduled reports are sent to the Joint Use Board by regularly scheduled meeting date 100% of the time, regardless of meeting cancellation. Emergency generators at the facility are checked monthly by a fuel distributor to make sure they are operational in case of power outages 95% of the time. Automatic test runs on generators are performed weekly 95% of the time to ensure the units will start every time. Records of sludge accumulation are kept daily 100% of the time. So sludge accumulation on site will be kept at 80% of the metric ton limit 90% of the time. Sludge will be worked daily 95% of the time in an effort to achieve Class A compost qualities. Operators will train and test to achieve a wastewater operator level 4 within 6 years of hiring 80% of the time as their difficult test to pass. All operators will obtain the required 30 hours of continuing education every 3 years to maintain certification 100% of the time. Membrane bioreactors, filters will be inspected, cleaned, and replaced as needed every 6 months, 90% of the time. Wastewater effluent, and metering station meters will be tested and calibrated a minimum of once per year by a qualified third party. The Joint Use Board will be notified of the ability to meet the level of service criteria annually on the earliest regular meeting of the calendar year. Any questions on any of this stuff?
No, is this an industry standard kind of thing, or is this something that I know the village, we've wanted to do our level of services to make sure we're getting what we expect, but also that we can afford it. So is this something that's kind of unique? I know you talk to your counterparts around the nation, or is this something in line with what people are doing?
Could you answer that, Eric?
So these are internal guidelines. So, obviously the plant is operated based off of our regulatory requirements, but this is a target that we're setting for certain things. So, we don't want to be operating the plant and discharging effluent that's right at the NPDES permit limits, because then Isaac has no leeway if there's any type of equipment failure. So he's trying to shoot below that, because then if we have some equipment failure, he's got a little bit of wiggle room. It's not that we're bound by this, it's just a target for it. Most all of this stuff shouldn't really result in a increase of expense. A lot of it is actually in place to help reduce expense. So with like the optimizing the chemical dosage once a day, those chemicals are very expensive, and so by making sure that we're only dosing the amount that we need, we'll save a substantial amount of money. The other thing is, like with the sludge beds, only having a certain amount on there, we don't want to get right up to that threshold of our permit limits. We want to make sure that we have adequate space for his sludge to be processed.
Okay. Does anybody, yes, sir,
Mr.
Councilor
Mayor.
Jackson?
Oh, thank you, Mr. Mayor. I just had a question, in reading through this, would it be easier, given just what you said, Eric, and also Isaac, knowing how he's tied to making everything work correctly, just to give your target goals the same throughout the document, as opposed to bouncing between 90% and 95%?
We can look into that, Eric, if you want to, and we can get all that changed.
Yeah, it's, we were just, basically some of the higher percentages were things that, sometimes there's instances, like the goal is that we wanted to get it done all the time, but sometimes there's instances where we might not be able to get the contractor out to check the generator. So that's why there's a little reduction in that. Some of the other components where it's, specifically 100% of the time, that's really us just acknowledging that it's a regulatory requirement. And so that's why we put that in there. We'd be happy to look at changing some of the percentages, but, Isaac and I went through this line by line, and we wanted to make sure that he had goals that he could achieve. And we didn't want to set it too high on certain aspects.
Well, I'd say compliance with 95% is a fairly high bar. I'm just, as long as you're comfortable with it, Isaac, because you're the one in control of it. That was my only question and concern.
Yeah, we went through it, and I always try my best to do things right 100% of the time, and that's why we I know that 95% kind of seems kind of high, but we try to do things right, 100% of the time. We just kind of went a little bit lower just to try to get this level of service out.
That's all I had, Mr. Mayor.
Okay. Does anyone else have any questions? Comments? Okay. Thank you, gentlemen. So we'll need to take action with a motion to approval to accept the level of service.
Mr. Mayor, move to adopt resolution 2020-04, a resolution adopting the regional wastewater treatment plant level of service.
Second.
Okay, was that Joey?
Yes, sir.
Okay, thank you. No further discussion? Roll call, please, ma'am.
Counselor Jackson,
Aye.
Joey Jarvis,
Aye.
Mayor Crawford,
Aye.
Mayor Holman,
Aye.
Counselor Cornelius.
Aye.
Thank you.
All right, gentlemen, number 3, presentation on reuse technical memorandum by Derek Belka with Mosen Corbin and Associates. Item number 3. And so do we have Derek? Yeah, I see his name up there. Go ahead, Mr. Belka.
Can everybody see my screen and hear me okay?
Yes, sir.
Alrighty. Well, as the agenda memo said, this is a presentation on the reclaimed wastewater reuse technical memorandum for the Village of Ruidoso and City of Ruidoso Downs Joint Use Board. I am Derek Belka. I'm a registered New Mexico professional engineer in the state of, I'm registered in New Mexico. For those of you who don't know me, I'm a water and wastewater treatment specialist with Mosen Corbin. I'm also a University of New Mexico graduate researcher. focusing on biological nutrient removal in wastewater treatment processes. And I've done several projects in and around Ruidoso, and specifically several projects related to nutrients at the wastewater treatment plant. I do have a lot of information to cover today. The report goes well beyond what I'm going to discuss, but I'm just going to try to give you all an overview of what are some of the key considerations, what are the different projects that we looked at potentially doing pursuant to reuse, and what the JUB might consider for moving forward. So when we're talking about reuse, there's several different kinds of reuse that generally fall into two categories: above ground and below ground. I've listed out several here. This is not an exhaustive list, and we're not going to talk about all of them today. So the ones we're really looking at for the joint use board are irrigation crops. That's usually fodder crops, grasses, alfalfa, that sort of thing. Green spaces like golf courses and parks. Possibly reservoir augmentation, which is a potable type of reuse. And then in the below ground category, we'd be looking at aquifer replenishment or recharge. And that could be either a non-potable or a potable reuse category. So why would we look at doing this? Well, reuse is often used to enhance drought resiliency by reducing reliance on potable water resources for non-potable uses. So, most communities out there, they're using potable water to irrigate parks and golf courses, other green spaces, that sort of thing. And we want to try to reduce that so that your potable water resources are available for potable uses. Reuse also helps reduce reliance on lower quality water sources, so you may be supplementing your higher quality water resources with lower quality water resources in order to meet peak demands that you have. It also can help improve the quality of life by maintaining green spaces even during periods of drought. It also kind of just reiterating some of those previous bullets that it can provide a high quality resource for supplementing your other supplies. But in this case, Ruidoso, or the Joint Use Board, the Regional Wastewater Treatment Plant, we're looking at kind of a unique reuse application where we are trying to reduce direct pollutant discharges to the Rio Ruidoso. And how we're doing that is, I'm sure most of you know, the wastewater treatment plant and EBES permit has a mass-based loading, so that is flow times concentration equals the mass out of the treatment plant. And if we can reduce that flow portion, that can theoretically increase the concentration that we're allowed to discharge at. Which is actually this is kind of a great segue from the information that Isaac and Eric just presented on, running that treatment plant at a very high level of service. This would maybe potentially reduce those target levels of service for some things to make it easier to operate the plant and make sure that we're not violating any of the treatment requirements for being EBES permit. Okay, in the state of New Mexico, there are not actually any regulations, direct regulations dealing with reuse. The New Mexico Administrative Code requires you to receive a discharge permit, but the classifications of wastewater and their potential uses are not listed out in the New Mexico Administrative Code. But in 2007, the Groundwater Quality Bureau published the above ground use reclaimed domestic wastewater guidance document, which lists out those classifications and possible reuse categories. In Ruidoso and Ruidoso Downs, we're most interested in the two highest classifications. These are all non-potable reuse classifications. So we'd be looking at Class 1A or 1B. Just a little bit of a note that 1B requires a 100-foot setback from the public, or irrigation practices that limit potential for public exposure. So that might be, irrigating at nighttime only, so that you're not exposing the public to the reclaimed wastewater while it's being used. And then just another little note that, any higher classification can be used for a lesser classifications purpose. So Class 1A can be used for 1B purpose. Class 1B can be used for a Class 2 purpose, and so on. down through all the different classifications. So how is the wastewater treatment plant doing relative to those criteria? In this table, I've got the class 1A and 1B limits shown, and then in the very far right-hand column is the wastewater treatment plant's performance over the last several years. And for BOD or biochemical oxygen demand, TSS turbidity, the wastewater treatment plant is doing quite well and meets the class 1A criteria quite frequently. The main issue is the fecal coliforms. The system was just not really designed to achieve a 1A level of disinfection. It was designed to achieve something closer to class 1B, which is what the requirements are for discharge. So if we were looking to make the shift from 1B to 1A, there would need to be some upgrades to the disinfection system. Okay, now the important part, the nutrients. There's a lot going on this graph, so I'm going to try to help you unpack it here a little bit. On the left-hand y-axis is total nitrogen, and all the orange lines and dots are related to total nitrogen. On the right-hand y-axis is total phosphorus, and all the blue lines and dots are related to total phosphorus. And these two solid lines, kind of in the middle of all these dots, are the current wastewater treatment plant's mass loading limits turned into a concentration. So it should be fairly evident from this graph that the treatment plant does pretty well about being below both of those lines, those concentration limits for both nitrogen and phosphorus most of the time, but occasionally there are some excursions above those limits. So in looking at reuse and going back to the fact that we've got the wastewater treatment plant has a mass-based limit, if we can reduce the flow into the river, we can increase the concentration that we can discharge without exceeding the mass limit. So we somewhat, or not necessarily arbitrarily, but we picked a limit where we're fairly confident that the wastewater treatment plant can operate below that line 95% of the time or better. And that corresponds to about 5 milligrams per liter of total nitrogen. And then if we apply the same flow for phosphorus, it ends up being about 0.225 milligrams per liter total phosphorus. As Isaac was talking about, and Eric were talking about, the type of phosphorus removal that we're doing here is chemically driven as opposed to solely biologically driven. And so we can't really relax the phosphorus concentrations to a point where we would eliminate chemical phosphorus removal. But we are at a point where even this shift from being around 0.12 milligrams per liter of total phosphorus up to about 0.225 can have a very dramatic impact on the amount of chemical that needs to be used in order to hit that level. So there will be some positive benefits there. All right. So how much water do we need to be reusing? So this graph shows, since we're using total nitrogen as the sort of the main parameter which we can relax based on, we need to limit the discharge from a wastewater treatment facility to about 0.9 billion gallons per day. And so that means anything above 0.9 billion gallons per day needs to be reused. This gray line represents the average wastewater treatment plant discharge over the last year. I believe that was 2019 average, was about 1.4 million gallons per day. So we need to be reusing about 500,000 gallons per day, which is not an insignificant amount given that that's about a third of your total wastewater treatment plant discharges. So that's pretty significant. And then as flow to the wastewater treatment plant increases, obviously the amount of wastewater that will need to be reused increases correspondingly. So where might we reuse this water? One of the projects that we looked at and discussed, and something that was vetted at the workshop that we held with the JEB last year, was looking at downstream irrigation. of agricultural users. So downstream of irrigation just means downstream of the wastewater treatment plant. As I kind of said earlier, the treatment plant gets a class 1B, which is usually good enough for most irrigators. Sometimes they want a class 1A, and we need total nitrogen less than 10 milligrams per liter. That just makes management discharge easier, and the treatment plant gets that objective no problem. One of the biggest issues is the seasonality of irrigation, particularly for agriculture. Since we're looking at this reuse as a strategy to limit nutrient loading to the river, we have to have a 24/7, 365 reuse strategy. We can't be looking at something that's seasonal. And so this graph on the right is trying to show what the safe application rate is, or what we might consider to be the disposal rate, the rate at which we can apply reclaimed wastewater to essentially an open field without degrading that field to the point where we're going to start seeing erosion or turning it into a mud bowl. And what the y-axis is showing here is the thousands of gallons per day that need to be applied over 100 acres to be disposed. So it takes about 100 acres to safely dispose of around, I think it's about 380,000 gallons per day. So if we need to be up here around 500,000 gallons per day, we need over 100 acres of land that we're applying reclaimed wastewater to 24/7, 365 in order to make this a viable strategy. A couple other things about a project of this nature is that not only would the wastewater treatment plant need a groundwater discharge permit, but each individual user that you are sending reclaimed wastewater to would also need a permit that they would need to hold to. And also a key issue with this is when you start looking at reuse, your water rights portfolio can become very important. In the city of Ruidoso Downs, their diversions don't require any return flows to the Rio Ruidoso. But the village of Ruidoso has a pretty significant chunk of water rights that are used that rely on return flows into the river. So if we start taking away those return flows, we have to be very careful about how the water rights portfolio gets managed. And so, I mentioned that we're going downstream. This map here, this table shows you or gives you an idea of what that really means, where there's acreage available with irrigable property. So downstream of the wastewater treatment plant, we've got about 3 miles, or that zone we're calling is about 3 miles from the treatment plant. There's about 180 acres of land available, and we estimate that it would cost about $4 million in pipeline pumping and storage facilities to transfer reclaimed wastewater into that area. And then we also identified down and around Glencoe, which is 3 to 7 miles from the treatment facility, there's around 350 acres. To get further down into the San Patricio area, there's almost 700 acres available. As you get down even further towards Hondo, there's around 500 acres available. And that's not necessarily that all of these acres would be irrigated, but that these are the areas to target that could have some people in those areas that are interested in reuse. Okay, the next potential irrigation project is looking at green spaces. Again, class 1B is fine, but class 1A works a little better. Seasonality, again, is a big issue because you need to be applying 24/7, 365. The distance that we'll see here in a second from the wastewater treatment plant lends some credence to the idea of scalping facilities, which we'll also talk about today. And then I just wanted to note that a project of this nature would likely require an MDOT permits and several crossings in the Rio Ruidoso in order to bring reclaimed wastewater back into the communities. So this map here shows the wastewater treatment plant way out here on the right. Generally, for the purposes of this study, we assumed that the reclaimed wastewater pipeline would kind of follow the alignment of the existing interceptor back up into the community. These green splotches on the map are different areas that could be irrigated with reclaimed wastewater. And I think one of the key takeaways from this map is that the most acreage that's available is the Links Golf Course and the Cree Meadows Golf Course within the village of Redusco. And that's pretty far away from the wastewater treatment plant. So we need to, that could have pretty significant impacts on the cost. So those are the irrigation projects that we could look at doing. And now this next category of projects would be potable reuse. There's several different kinds of potable reuse. One of them is often referred to as incidental or de facto indirect potable reuse. And that's basically just there is a wastewater treatment discharger upstream of a drinking water treatment plant. So here in Albuquerque, we engage in indirect or incidental or de facto indirect potable reuse on a daily basis. The city of El Paso has kind of recognized that, yeah, they're drinking Las Cruces' wastewater, so they are very cognizant of that in their treatment choices. And then there's planned indirect potable reuse, where you discharge into an environmental buffer, such as a reservoir or an aquifer, before taking that water back out and treating it and sending it in your drinking water system. Or there's direct potable reuse, which is what Cloudcroft is doing, or what they're trying to do. And that is not something that we are looking at. That is another category. And then this table here on the right just shows kind of the status of current reuse regulations in the Southwest. And New Mexico basically has nothing in place, whereas several of the other states have started to put potable reuse, or recognize the need for potable reuse and are starting to pass regulations and guidance and things like that related to those kinds of projects. Okay, so if we were to look at doing one of these kinds of projects, there's a lot of information on this slide. Basically, what I want you to understand is just that it requires a very high level of treatment. You know, we're taking a reclaimed wastewater that's already very high quality, and we're subjecting it to a series of treatment processes that fundamentally alters that water and purifies it to an extent that it's often more clean than what people see in their drinking water systems. And actually, one of the criteria that was put into the city of Rio Rancho's permit, which is an indirect potable reuse permit, basically NMEG is requiring them to produce a drinking water quality water before they discharge it into their environmental buffer. And then when they take it back out of the ground, it's again make sure that everything is drinking water quality standard. The main issues with this application in Ruidoso are that the effluent is currently from the wastewater treatment plant currently has a TDS greater than 1,000 milligrams per liter, which is a criteria that's listed in that New Mexico Administrative Code section. And it also exceeds the value for chlorides, which is 250 milligrams per liter. And then although hardness is not actually listed as a treatment requirement, I felt that it was necessary to include this because it becomes an important part of our conversation later on. So the two types of indirect potable reuse for the JEP that we're looking at are aquifer storage and recovery, and then surface water augmentation project. So an aquifer storage and recovery project, this flow diagram on the left kind of shows you what's entailed. But basically, wastewater is taken, treated to a very high level, sent through an advanced water treatment plant, injected into the ground, left into the ground for a minimum of 9 months before it's taken back out and sent out for use in the distribution system. There's two aquifers that could be targeted. One of them is the Links Golf Course, There's a non-potable aquifer that underlies the Lakes Golf Course that can be used in a non-potable application. Or there are some wells in the Upper Gatlin Canyon region that were identified by the village's hydrogeologist as potential locations for recharge and later extraction. There's a good potential for a synergy with the village is currently working on a project to use excess drinking water from the Alto water treatment plant to do an aquifer storage and recovery project, and that water could end up being blended with reclaimed wastewater in the future if that is something that gets pursued. The additional treatment steps that are required after we've achieved the Class 1A wastewater are desalination, because we have to knock that total dissolved solids below 1,000 liter, and then an advanced oxidation process. And the other infrastructure that we require is transmission pipelines and pumping facilities, injection and recovery wells, and obviously wastewater treatment. For the other kind of project we looked at, which was the surface water augmentation project, the Grindstone Reservoir was the most convenient because it's a relatively large reservoir compared to the rate at which the Grindstone water treatment plant produces water. It has a very long residence time. We estimated that it would be over a year if you, to turn over the reservoir, if you were only discharging 500,000 gallons per day of treated wastewater into the reservoir. So that's a very long residence time. That's a good thing. Again, the additional treatment required, we would probably need to desalinate, and then we would need advanced oxidation before and after the reservoir. And other infrastructure would be transmission pipes and pumping and wastewater. The main issues with either one of these projects is that currently it's hard to know what to expect from a permitting perspective. The ASR project, the Aquifer Storage and Recovery Project, there is one in the city of Rio Rancho that currently is in operation. So their permit can reasonably be used as an expectation for that kind of project. But we do not have any surface water augmentation projects in New Mexico, so it's hard to know what might be needed there in terms of regulatory requirements. But at the very least, we know it would require an extensive environmental study and reservoir modeling. One of the key issues with the fact that New Mexico does not have any explicit reuse regulations is that the requirements of these permits can be open to interpretation or policy by the current bureau chief. So they could decide, that guidance document that I showed earlier, or the table in that guidance document, was produced in 2007, and there have been a lot of changes in the reuse technology space that have occurred since then. So there's a good chance that that document could be revised, and depending on the inclinations of that bureau chief who's in charge of revising that document, we may get less stringent or we may get more stringent treatment requirements. Public perception is a huge issue, and effective PR campaigns are one of the most important components of these kinds of projects. And then if you were to implement something like this, the operations are very, very complex, and there's a lot of performance testing and verification that has to go on a monthly basis to show that you're not discharging anything into these systems that could potentially impact public health. And then, since we have to do desalination, that process, although it has gotten much better in the last 10 years, it still has a very concentrated solid waste stream that needs to be managed. Okay, so that was the 4 potential endpoints that we've looked at, and now we have to look at where the wastewater is coming from. If it's coming from the wastewater treatment plant that currently produces the Class 1B wastewater, we would need to get it to Class 1A at least. We would need to build some storage and pumping facilities. If desalination and advanced oxidation is required for an indirect local reuse project, we would need to construct those facilities as well. And as I mentioned, that desalination waste stream it's costly to manage because we would need at least 30 acres of land in order to evaporate that solar evaporation to eliminate that waste stream, which is not an insignificant chunk of land. And this figure just shows what those facilities might look like on the wastewater treatment plant campus. We try to maximize reuse of existing facilities that are in place, but unfortunately, we would have to build a new building to house the advanced treatment equipment for an IPR project. The other option is to build a scalping plant. The image on the left here is a packaged wastewater system from Aviva that at this time was being installed at Tauski Valley. Generally, these package systems can achieve the same level of wastewater that your current treatment facility achieves. But one of the main issues, and actually I'm going to skip ahead a slide here, is that we need to site this in a location where it's not only close to our reuse endpoints, but also where we have a consistent supply of 500,000 gallons per day of wastewater flowing through the system. Through the fairly extensive previous flow monitoring campaigns that we've done, that area is kind of around the confluence of all the collection system, right there around the Downs Village of Ruidoso boundary. So that's where we would be looking to site a scalping lift station that would pump water back up Gavilan Canyon to one of these potential sites, kind of in between the high school and the transfer station, where there's some available land that actually the village purchased for the purposes of developing water resources. And so that's where we might look to site a scalping facility. Again, it would be used to produce a Class 1A reclaimed wastewater, and then if we were pursuing an indirect global reuse project, we would need to site those same facilities on that scalping site. Okay, that's a ton of information, and I talked about kind of 4 different possible endpoints, 2 different potential sources. So we threw together some, put together some potential project configurations, and really what the gist of this slide is intended to convey is that irrigating downstream agriculture is going to be your easiest, least costly option, but will have issues with water rights that could make that project limited in its scope. The other 4 options for IPR or even for irrigation of green spaces are pretty costly, and that has to do with the fact that the sources of wastewater are fairly far away from the reuse endpoints. As I tried to iterate before, we're trying to reuse roughly 1/3 of the wastewater that comes into the wastewater treatment plant. That's a huge amount. And so the things that we might look to do to reduce that, or I'm going to talk here in a minute about things that we might do to reduce that, because if you could cut that amount in half, so let's say we cut it down to 250,000 gallons per day, all of these total cost figures are going to be reduced by 30 to 40%, just because we don't have to purchase as much equipment to provide the treatment. So we'll talk about that again here. Another component of this study that kind of goes back to the level of service that Isaac and Eric were talking about was looking at power optimization. So is there a way that we can save money by optimizing power use at the wastewater treatment plant? And currently, the wastewater treatment plant uses a non-peak power billing for most of their electrical meters. So that just means that they pay one rate throughout the day. There is no on-peak, off-peak, and that's actually advantageous because Isaac and his crew equalize flow through the treatment plant so that there's a relatively steady 24-hour operation. So that means that basically we try to look at one way we might optimize power is to pump only at night versus pumping during the day, which would be a peak billing time. But that would cost essentially the same no matter what we did. And then the so the main cost difference there, or the main driving factor for that would be new infrastructure costs. If you're only pumping at night, you have to pump the same amount of volume in half the time, so you need to build a bigger pipeline and pumping facilities, which is going to cost you more money. And this strategy is not uncommon, the power optimization, but it's usually done when you have existing infrastructure that has unrealized capacity and you've got that on-peak, off-peak building time. The other component of the power evaluation was to look at solar. The wastewater treatment plant has 3 meters. The main meter is a pretty substantial power load. In this green table, it shows the system size, solar facility size required to completely offset that meter. So the main meter is 1.7 megawatts. The old plant and the west electrical room are much smaller. And then these areas that are highlighted in the map are areas where you might build a solar facility within the existing wastewater treatment plant campus. The north end of the property has some complications with the existing overhead electric easements that would require that to be relocated. But the blue table shows how much it would cost you to build these sizes of facilities, and an estimated return on investment period. 15 to 25 years is not uncommon for photovoltaics, especially because power is relatively cheap in New Mexico. Okay, so kind of bringing this full circle, the recommended next steps, when we looked at that cost slide, a reuse project is going to be very expensive in its current form. So if we can reduce flows or pollutants that are coming in to the wastewater treatment plant, kind of up that reclaimed wastewater quality without having to provide any actual additional treatment at the wastewater treatment plant, we believe that looking at water conservation from 2 recent documents, both for the city of Ruidoso Downs and for the wastewater, and for the village of Ruidoso, we believe there's probably more than 100,000 gallons a day of flow reduction potential from more aggressive water conservation practices. Similarly, if we can reduce the I&I in the collection system or infiltration and inflow, we think that there could be up to 100,000 gallons per day or more potential to reduce flow to help out allow a higher nutrient concentration discharge from the wastewater treatment plant. And then one of the big issues, and why I had that hardness value listed earlier, is that the point of use water softeners are fairly widespread in the village and the city, to our knowledge. And that usage, because you take the hardness out for your individual home, but your water softener doesn't actually really sequester that. You actually end up discharging all of that hardness usually into the wastewater collection system, and all of the salt content that was associated with the hardness removal also way into the wastewater treatment system. So when we analyzed, what does raw water quality for both of these communities look like compared to wastewater quality, we saw a very, very substantial increase in salts and hardness, and we believe that could be due to point-of-use water softeners. And there are some alternative technologies that could be that residents could be encouraged to employ that would not have the same salt concentration effect in the collection system. So as you go through looking at these different flow reduction and pollutant reduction strategies, over time you want to collect and analyze data and then reevaluate your reuse volumes and treatment. As I said, if we could cut down the amount that needs to be reused in half, that has a pretty substantial effect on the overall cost of the system. It may begin to make some of those projects more viable. And one other thing I did want to mention, sort of in conclusion here, is that right now there is a ton of funding available for reuse projects and energy efficiency and resiliency projects. The USDA, Bureau of Reclamation, and EPA all have funding programs that are currently very underutilized, and they actually are sending out fairly frequently sort of begging people to apply for funding because people are not utilizing that.
Derek,
Realize that? Yes, sir.
Derek, this is the mayor. You kind of cut out right there at the end. So you said these funding sources are readily available for the reuse or what was that? Or upgrading plants or whatever? Could you touch that again?
Yeah. So the USDA, Bureau of Reclamation, and the EPA all have funding sources that are explicitly, well, I guess they're not necessarily saying this is for reuse, but they're for like drought resiliency programs, and they're all vastly underutilized. We get requests pretty frequently from the USDA and Bureau of Rec to ask our clients who might be looking at these kinds of projects because there's funding programs that are very underutilized. It's the federal government, so if they don't use their budget, they can't justify it the next cycle, and they don't get the money anymore. So they're trying to get us to utilize these projects more, or utilize these funding sources more frequently because they're currently underutilized.
Okay, thank you.
Yeah. So I realize that that's a ton of information, and the document itself also has quite a bit more discussion on each one of these topics. So I believe there's a copy of the draft available, but we should be working through some of the comments we've received from Isaac and Eric, and putting together a more finalized draft that would be available for review. And so if there's any questions or comments that come to mind, please feel free to email myself or Jerry Paz, or give us a call.
Okay.
So with that, I just thank you very much for your time today. If there's any questions, I'm happy to answer them now, or if you'd like to move on, that's fine.
Okay. Thank you, Derek. Does anyone have any questions for Derek?
Derek?
Mayor Holman?
No, thanks.
Counselor, do you have one?
The biggest concern I've heard in the whole presentation was the loss of return flow credits.
Right.
And so I don't know if he calculated what that could possibly be, but that's an important issue.
Derek, did you hear that?
Yeah, this is something that Eric and I have been, or have discussed quite a bit. So the loss of return flow credits, I think is most important with the irrigation projects, particularly the downstream irrigation projects, and that's kind of why, or what helped, or forced us more to look at a potable reuse strategy. Because if diversions, allowable diversions, are tied to return flow credits, we want to be replacing a water use that requires those diversions in the first place. And so if you're talking about a potable reuse project, that diversion reuse trade-off is easier to manage because you're directly replacing water that you would have diverted from a potable water source. That said, in both the village and the city, there's still a decent amount of water that is diverted that does not have a return flow credit tied to it. And so if you do some, I hesitate to call it creative accounting, but if you account for the water and the wastewater in a little but creative fashion, you can reuse a fairly substantial amount of that water without impacting quality.
Okay.
The only follow-up question I would have to that, and I'm sure Eric has probably looked at this also, is are you going to have some of the same issues with the use of scalping plants?
The scalping plants, there would be essentially no difference from from a water rights perspective, because it just matters where you're taking the water out of the system. But either way, the wastewater that comes out of the wastewater treatment plant into the river is what's going to define your return flow that you're allowed to claim.
Okay, thank you. Anyone else have a question? Okay, I got a crazy one. Okay, when you were talking about funding sources, loans, USDA, and Bureau of Rec, is that recreation?
Bureau of Reclamation.
Reclamation. Oh, I was hoping recreation. So the above ground potable use couldn't be a lake in the downs or any place like that the water could be used for. That could be used for storage and then the expense would be added to that for pump back. But that's not even an option.
There could be discharged into, like you're saying, an impoundment of some kind within the city of Ruidoso Downs. I'm not personally aware of somewhere in the Downs where that it currently exists. That doesn't mean that it couldn't be developed. Just that this was sort of a high level study of looking at what are the options based on what's currently there, with the exception of scalping plants.
Okay.
And so I think that that's certainly an option that could be pursued if there's an area that's identified as a potential site for a lake development that could be for a recreational use and storage for irrigation water or something like that.
Okay, that'd be awesome if Ruidoso Downs had its own lake. So anyway, back to another question. Water softeners, you mentioned about citizens, people in the community using those. Can you touch on that a little bit? Is that a big impact to the plant?
Yeah. So looking at your reclaimed wastewater quality versus the raw water quality, there's kind of there's two smoking guns there that clue us into that's a pretty big impact. The first one being, so the way that softening process works is that there's an exchange of the molecules that cause hardness, so that's calcium and magnesium, with molecules that don't cause hardness, so that's usually sodium or potassium. And then, as I'm sure most of you are aware, you have to have, or most systems have, separate salt or brine solution that is used to recharge your softening system. So it traps the hardness that would go into your individual home, but that hardness is ultimately released into the collection system when you recharge the system, along with all the salt that is used to recharge the system. So the main, and actually we believe that's a pretty big source of the chlorides that end up in the wastewater treatment, in the wastewater. I mean, that goes up, usually we see, maybe up to 100 milligrams per liter increase in a very arid area that's doing a lot of water conservation. But in the village of Ruidoso, we're seeing something more on the order of like 200 milligram per liter increase in chloride. And so like I said, that's kind of a smoking gun for point of use water softeners being very widespread and contributing significantly to water quality. Because chlorides can get into the system from other uses, but in the village and in the city, there aren't really any major industrial dischargers that we might look at and say, oh, maybe this person or maybe this business is discharging a significant quantity of chlorides.
Well,
Does that make sense?
Yeah, I can tell you it's a significant business here. But you said that can also be exchanged for potassium, would do the same thing?
Yeah, sometimes, or I've seen systems. I think they're very uncommon because I believe the potassium chloride salt is more expensive and less effective, like per pound of salt than standard sodium chloride.
And Eric, the only time I've seen that utilized are in cases where individuals can have high salt contents in their water that they're drinking. Even though the proton is K plus 1 or sodium plus 1, and the exchange is 2 to 1 because obviously the calcium is plus 2, as is the magnesium. So I don't see that occurring very often.
What do you see what occurring?
An
Use of it.
exchange of sodium as an exchange resin for potassium. Very rarely do I ever see it. It's only in those very specific circumstances. On the flip side of that, if you have someone that is utilizing dialysis, you can't use potassium. So I think that's the reason it's avoided.
Okay, I got you.
So what are the other options? Because we do have severely hard water, and everyone I know has a point of use softener. So if you're saying we're causing ourselves a big issue down the line, so what are the steps? I think that's something, I know we're not going to cover that today, but I think in this reuse and some of these other issues, that needs to be a big point of discussion. You know, we've already gone into our soaps and gotten rid of all the, what's the cleaning? Nitrates. So is this something that we're going to need to be looking at in the future? And if so, we need to start working on a plan for that now. And I know we don't need to go into all that today, but I always wondered if that was a big source or a big problem. And it sounds like it could be becoming one.
But Eric, wouldn't chloride levels remain the same regardless?
Would chloride levels remain the same?
Yes, because if you're using sodium chloride or potassium chloride, the chloride is still the exchange.
Yeah, so the chlorides would still be involved in the recharge process, and you'd still have chlorides as an issue, but potentially lower total dissolved solids or different total dissolved solids.
But if we need to reduce those things, you know, in the future, I think that there needs to be some thought on what are the alternatives to those two programs. Are there alternatives that we can start talking with our local water companies that are pushing those things and educate our citizens like we did with the nitrates and other things? That's kind of my point. So anyway, okay.
Yeah. And there are alternatives for that, and that is discussed in the report a little bit. Although it's not focused on the report, it is mentioned in there.
Okay, Cornelius has something.
Derek, it's John. On the softeners, most of the time when we put them in, we put the backwash into the sewer system. Occasionally, we'll just run them out onto the ground. If we ran them all out on the ground, would that create just a different set of problems, or would that help?
I'm not familiar enough with your building codes to tell you whether or not that's a problem, but that could be into the collection system may actually technically be required by building code. If they were run out onto the ground, I mean, you're going to be salting up the ground in that area, obviously. So you wouldn't be discharging out of the collection system, like you may be making a bigger localized problem on someone's individual property.
Yeah, that's what I was wondering. A lot of our groundwater is so deep, it'd take a while to get there, but. Okay, well, thanks.
Oh, and one last question, Eric, because I was trying to follow through this. I'm just asking your help. What would be the steps and the complications of going from a 1B system to a 1A system? As I understood it, there would be a significant financial responsibility. And also, I'm not clear on what we would be doing currently that would be different.
Yeah, so there's a couple of different ways that you could accomplish that. If you're going, for a downstream agriculture project, just as an example, if we needed to get Class 1A, that would require modifications to the disinfection system. But one of the good things that you can take advantage of, it really all depends on your permit, what your point of compliance is. And so the point of compliance is maintained as the discharge side of the existing UV system. you would need to introduce some additional treatment upstream. So from a UV perspective, that would be additional lamps at a higher intensity. So you could replace the existing, you might be able to replace the existing system with a higher intensity system in the same footprint. I'm not 100% sure on whether or not you can do that. We would look at that specifically in detail. The other potential is that if your point of compliance is further away from the wastewater plant, when we do reclaimed wastewater projects, we almost always have a small dose of chlorine that's added into the pipeline before transmission to prevent things from growing in the pipeline and causing problems. And so that even that small dose of chlorine, if your point of compliance or disinfection is further away from the treatment plant, that may accomplish the additional disinfection that you would need to meet the 1A requirements. So it's either an increase in lamps and intensity for the UV system or some kind of supplementary chlorine system.
So it's specifically addressing then coliforms, is that correct?
Yeah, that's the marker organism that's used to determine disinfection effectiveness. And so it would, you'd be looking at trying to reduce the coliforms to that 1A level, which is substantially lower than the 1B level.
Okay, anybody have anything else?
Derek, could you email me one of the final documents when it's done?
Will do.
Thank you.
Okay, thank you, Derek.
Yeah, thank you for your time. I appreciate it. And everybody have a good day and be safe.
All righty. Okay, we'll move on to item number 4 is project update for sanitary sewer repair rehabilitation FEMA 1783 PW 155, and that is Karen Gutierrez. Karen,
Hello.
Hello.
Good morning, Chairman and members of the board. I'm Karen Gutierrez, the Assistant Finance Director and Capital Projects Manager. I'm going to share my screen with you. I'm hoping to get this up so that you all can see and see if I can make this bigger for you all. So that we can let me zoom in. Is that a little bit better? I don't know if y'all are able to see.
we don't have anything on the screen. We're not seeing it.
Okay.
It looks like you need to open your Word document.
Yeah, see, it's showing that I'm sharing, but it's not coming up.
Karen, when you click the share screen, you accidentally clicked the email, the Outlook only. You want to click the button that says share the whole screen, and then it will show everything that you're seeing.
Thank you, Eric. Now if I get back to it. Okay. Now I just need to go into my document. Is that better?
Nope.
You see, still not?
No, ma'am.
Okay. All right, well, I'll provide the update and then I can email this document to you. It's just a snapshot of what's happening for the sanitary sewer project. And I wanted to start it off with a survey update. Moser Corbin now in the midst of wrapping up their surveys. Their design is due by July 14th, 100% design. And with that 100% design will go to FEMA EHP and to the Army Corps of Engineers so that they can start reviewing and working towards their determination. Right now, SHPO, there was 2 phases we had to work with getting the State Historic Preservation Office concurrence. 2 packages were formulated. The first package was delivered. SHPO has reviewed it, had no comments, and approved it. Package number 2 from the FEMA EHP office delivered package number 2 to SHPO. They're in the midst of reviewing it. Their schedule was to have that review completed by mid-June. but due to COVID-19, they have now stated that review will be completed in the middle of July. Once FEMA Environmental Historic Preservation Office and the Army Corps of Engineers receives the final design, and if no significant changes were made, they will start a review, which will take, they have given us 60 days for review. And then the Army Corps can start working on the 404 permit, which they estimate that to take about 30 days. FEMA and Department of Homeland Security have been briefed as far as the new design schedule moving from May to July, so they're up to date on that. We do have a bi-weekly call scheduled for tomorrow, June 18th at 1 o'clock, and that's where we're hoping to get updates as where, if anybody has any issues or comments or anything for what we've been providing them. That's the time we like to get their concurrence, and then also we have any questions for them and give updates as where we are on our FEMA projects, not only the sewer line, but we also report on Post Road Bridge. The easements, we had a discussion with Mr. Koppler and Zach Cook this week. We feel like the final letters are being wrapped up as we speak. We're hoping to have those out to the property owners out on Monday. There are 9 property owners left as far as getting easements for the restoration phase and for the lift station phase. We have all 9 were contacted and have been briefed. Since that briefing, there have been 2 new property owners that have taken over. So we're in the midst of contacting them now to give them a briefing so that prior to any of these property owners receiving the letters and the easements, they are well aware of what's happening and how it affects their property. And so far, we have not received any pushback from anybody. So we'll be scheduling, since all of these owners seem to be out of town right now, we'll be scheduling either a conference call, Zoom conference, some kind of meeting so that we can sit down and discuss the letter, easements, and the exhibits to give them an opportunity to, if they have any questions, so that we're hoping this easement, that them signing and executing the easements will be a smooth process. Once we receive those easements back, Mr. Zach Cook's office will be filing them with the county clerk. For the first phase of this sewer line project, the restoration of existing sewer line and manholes is on suspension. It started the suspension on March 5th, in which we suspended for 90 days. We had to add an additional 120 days to that. So the suspension date that we currently have for SAK is through July 2nd. We have a meeting scheduled with SAK on June 30th to go over updates that we have that we're hoping to get from FEMA and from Department of Homeland Security tomorrow, and provide them those same updates, and then we'll be able to, hopefully, they do the project summary of all the changes of scope of work and the proposed suspension costs that they had submitted, that we have reviewed, that Moses Corbett has made some adjustments and some recommendation as to them addressing those. So those will be all discussed, as I said, on June 30th at 9 o'clock. We have a scheduled meeting for them. So with that, I could stand for any questions.
Thank you, Karen. Does anyone have any questions or comment for Karen? Okay, I think we're fine. Thank you, Karen.
Welcome.
We'll move on to item number 5, which is the Isaac Show for the monthly report on regional wastewater treatment plant.
Good morning once again, mayors, members of the board. This is just how we've done for the month, and we've been running really well. We're meeting permit Our flows are coming up a little bit on the weekends now substantially, but we're handling it and utilizing our equalization basins to divert that flow and treat it at a later date. We did start our fog program this week again. We gave the restaurants a little bit of a chance, but what we're finding is they're kind of behind right now, but we're getting it started again just to let people know that we're still continuing with this process. We're still removing 99.5 at least of everything coming into the facility. I did do 3 fog samples last month. I did the end of the Mountain Gods and Palmer Loop. They were 32.2, 47.9. We did do a Hollywood station, which pretty much shows all of the village of Ruidoso. It was 28.6. I didn't do an influent at our facility that month, but I did do one this month, so we can get a comparison of as to what the city of Ruidoso Downs is contributing, which is very minute. That's pretty much all I have. Does anybody have any questions?
Questions for Isaac? So, on the flows over the last month,
Yes, sir.
do you have a number there that's comparable to last year that's just quick at hand?
I do. Let me see.
I'm asking because our GRT numbers are coming in and we're not far off. And I was just trying to see if with all the traffic that we're having in town, a lot of that, it does equate to wastewater use, treatment plant use. So.
Well, it's kind of, it's not 100% accurate. It shows that we're showing less flow. I know we're really high, but it's because I've dialed in the plant to, well, no, that's actually what's coming in. No, it shows to be less, 1.09 right now as compared to 1.22 last year. So we did have more people at this time last year.
Well, and I mean,
and
that's reflecting in our GRT numbers,
Okay.
But I mean, the one that we got for this month, which is 2 months old, but I was just trying to see if the correlation still holds true, and it does. But but it's close. I mean, it's similar to last year's, my point.
Yes, sir.
Okay, that's all I had. Anybody else have anything for Isaac? Okay, thank you, young man. We appreciate your report, your time, and all your hard work.
Thank you very much.
You bet. Now comes time for the reports from our board members. Mayor Holman, do you have anything to report, discuss, or talk about?
No, Mr. Chairman, I don't.
Okay. How about you, Mr. Jarvis?
Everything's good here. I did want to tell Isaac, good job on his, working on his asset management. We've completed part of ours, and I know it's tough to do, and he did a really good job on that. Him and Eric.
Okay, thanks for that. Thank you guys for doing it. Counselor Jackson?
Oh, nothing at this time, Mr. Mayor.
Okay. Counselor Cornelius?
Nothing.
Okay. So we don't have anything from our board members. Do we have anything from the council? No. We don't have anything for closed session. And so we will call this meeting complete, and this meeting will be adjourned. Thank you, everybody, for attending. Sorry I was late.